Today we'll be talking about superglue and how its intermolecular forces contribute to its adhesive physical properties and other aspects of it.
Cyanacrylates are fast-acting adhesives such as superglue, which can be easily polymerized. Intermolecular forces are forces of attraction that act between neighboring particles such as atoms, ions, or molecules. There are three types of intermolecular forces that are present in cyanacrylates, such as dipole-dipole, London dispersion, and hydrogen bonding. The molecular geometry of a molecule determines the forces which occur through the molecule when the partial positive and partial negative charges in the elements share unequal bonding electrons. This is called dipole-dipole forces.
This is an example of a dipole-dipole force in these two polar molecules. Because with the water, because the oxygen is partially negative while the hydrogen is partially positive, it creates a net dipole movement that allows it to be attracted to other elements.
London dispersion forces are a temporary attractive force that results when the electrons in two atoms occupy positions to form temporary dipole forces. They are formed in all molecules. The temporary dipole moments allow the element to be attracted to another element or molecule.
This is an example of an atom having a temporary dipole moment because of London dispersion forces. It's because the positive protons go to one side while the negative electrons are at the other, creating a small dipole moment.
Hydrogen bonds contain a hydrogen atom bonded to an electronegative atom, such as oxygen, nitrogen, or fluorine. It is the strongest intermolecular force, and it contributes to physical properties such as adhesion and cohesion.
This is a picture that is an example of hydrogen bonding. As you can see, there are two water molecules, and the one hydrogen is attracted to the oxygen's lone pairs due to the oxygen's high electronegativity. Polymerization process. This is a process where small molecules called monomers, connect together to form one big molecule called a polymer that has stronger physical traits than the previous monomer. This is an example of an element undergoing polymerization. As you can see, these organic substances are all coming together to form a much stronger and more cohesive substance that has stronger intermolecular forces and physical properties. The most common form of superglue is methyl cyanoacrylate, and this is a picture of its molecular structure right here. Here in this picture you can see it has two oxygens, which are represented by red atoms, along with one nitrogen, and a series of hydrogens that are represented by white, and a series of carbons. This picture is an example of how methyl cyanoacrylate contains all three of the key intermolecular forces, allowing it to be able to have such adhesive physical properties. The reason it has all three of them is because all elements have London dispersion forces, and these are strong because of its high molecular mass, because of all its elements. And it has dipole-dipole moments because of its polar geometry, and partial negatives and partial positives throughout the element or molecule. And it has examples of hydrogen bonding because of its lone oxygen up here that can be attached to a hydrogen, as well as this lone nitrogen that can be attached to a hydrogen, which allows it to be more efficient. The effect of methyl cyanocrylate having all three of the intermolecular forces is that it has very strong adhesive power as well as strong cohesive physical properties. This allows it to more strongly attach to different substances, which allows it to be such a strong glue. Methyl cyanocrylate also undergoes polymerization. This is when the methyl cyanocrylate is exposed to the air's water vapor, and its aqueous hydroxides are bonded to it, allowing it to form this polymer out of the two methyl cyanocrylates, using the hydroxide as a system. The effect of this polymerization process is that when you release the superglue from the bottle, it is a liquid because it hasn't been exposed yet to the air's water vapor, and it seeps into the substance's pores. But then after it undergoes the polymerization process, it hardens into a solid while still inside the substance's pores, allowing it for such a strong state, which contributes to its adhesive properties.
There are many uses that we use for superglue, such as to put wood together. You can put the wood together by applying superglue to the wood. It'll temporarily allow you to hold the wood together so you can nail, screw, or fix the boards together. It can help you stop runs in your nylon or pulls in your sweater by applying the super glue on the start of the run. It allows you to seal the nylon so they no longer fray. And you can use it for auto maintenance, such as when you crack your tail lights, you can super glue them back together. Disconnected side mirrors, you can put them back on. Loose your rear mirrors the same way. And you can also use it for an emergency kit that's small enough you can fit it in the kit so it's easy access. You can put it over your blisters and it'll help keep it from irritating, and it can also be a quick and easy way to put a wound back together, such as a cut, and it's
These are some pictures that show common uses for superglue, such as healing wounds or putting broken objects back together.